Dear students, this is the fourth and the last module for studying Chow-Fasman algorithm. In this module, I'm going to talk about how to predict the turns in the secondary structures. We already know that we can find out alpha helices and beta sheets by looking at the specific propensities for individual amino acids as well as their neighbors by using the Chow-Fasman algorithm. In this module, I'm going to show you how you can actually find out the turns. If you look at this propensity table that we have been using in the 4 modules for Chow-Fasman, then you will see that in the third column, you have the propensity for each amino acid to form a turn. So this propensity is listed here, and more importantly, because turns are very flexible and of various sizes, so they have also considered the neighboring amino acids for formation of a turn. So in order to read this table, I will talk about the first example, that is alanine here. So the propensity for alanine to be in a turn is 0.66, and the propensity of alanine to be there in the first position after the turn is 0.06. The propensity of alanine to be there at the second position in the turn is here, at the third position and at the fourth position. So in this way, we are considering the neighbors as well. So if alanine is there at some specific site, then you can also see which amino acid is there at which other site, and you can compute their overall propensities. So let's take a look at an example. If you have the 4 amino acids given to you and you want to compute if they will form a turn, that is the secondary structure, then you can construct a tetrapeptide or 4 amino acids Fj, Fj plus 1, Fj plus 2 and Fj plus 3. So by considering these 4 amino acids together and looking at their propensity to form a turn, you can compute F total. So F total is simply the product of these 4 numbers or the propensity for the tetrapeptide. Next, you see the value P total, that is F total here, and if this value is greater than 0.000075 as well as the average value for this propensity in the turn is over 1 in the tetrapeptide, and thirdly, the alpha helix propensity here is less than the propensity for a turn, which is greater than the beta sheet, then it is a turn. So essentially, you compute the propensity of the turn, and then if this propensity is greater than both the propensities of beta sheet and alpha helix, then you classify it as a turn. So let me go over it again. So consider any 4 amino acids. You use the lookup table and you can find out their propensities to form a turn, and you can multiply them together in the using the equation given here, and you can arrive at F total. Now if the value of F total is less than 0.000075 as well as that the propensity for the turn is over 1 and that the propensity of this turn is also greater than beta sheet and alpha helix, then it is definitely a turn. So using this scheme, you can compute the propensities and the turns. Now this is all very complex, and here I will show you an online tool that does this for you. You can simply go at this URL at Virginia Tech, and then you can paste your sequence here, that is the amino acid sequence, and then of course you can predict which secondary structure can this sequence form. There are several other algorithms as well which have now been developed to predict the secondary structures and are based on other statistical as well as non-statistical informations as well. So in conclusion, Chow-Fastman was the seminal and the first algorithm to predict the alpha helices, beta sheets and turns from the primary sequence, that is the amino acid sequence of the proteins, and this algorithm is based on the statistical occurrence of amino acids within the larger UniProt database sequences.